everyone. My name is Iana Aranda, and I'm the Director of Engineering Global Development at ASME and the President of Engineering for Change. And it's my pleasure today to share this lecture with you on the role of technology for advancing sustainable development. Now, I want to start this lecture by talking about the drivers behind technology and where we are in terms of a global perspective. Technology broadly has really been immensely evolving. We live in an era where we collaborate across nations on the International Space Station, and we're able to edit genes with the assistance of approaches like CRISPR. But at the same time, what we're seeing is the continued challenges globally around essential infrastructure and technology. Globally, we see that a lack of basic services, critical infrastructure, and essential technology is leaving many populations, individuals in dire straits. At this time, 1.3 billion people are still not connected to the electrical grid. Over 6 million children die before the age of 5 annually. 40% of the population does not have access to dignified sanitation, and 29% of the global population lacks safely managed drinking water supplies. With the pandemic as we're experiencing in 2020, COVID-19 could push up to 100 million people into extreme poverty this year alone. And climate impacts, one of the biggest disasters and devastations of our time, could push 100 million people into poverty by 2030. Now, there's a framework to address these global challenges, and that framework is embedded in the United Nations Sustainable Development Goals. 17 goals adopted by heads of states in 2015 that cover everything from reducing poverty and reducing hunger to zero, through addressing climate change through action and delivering really a sustainable framework for partnerships across the globe to achieve these audacious goals. The unfortunate news is that as of 2019, when an assessment was conducted of the UN's goals, what we are seeing is that we are not on track to achieve the SDGs by the target deadline of 2030. What we do know is that in order to actually achieve these goals, what is absolutely essential is the participation of every individual, every organization. And in particular, what we need is a robust talent pipeline of technical and entrepreneurial talent that are prepared to engage effectively in addressing global challenges. Another important force is that within the funding community. Environmental, social, and governance, or ESG investing, is really taking some serious strides and is advancing our space at large. It is spreading to all pockets of the fixed income markets. In January of this year, BlackRock CEO, and BlackRock is one of the largest investors in the world, the CEO and chairman, Larry Fink, wrote a letter, his annual letter to the CEOs around the globe, stating that climate change is driving a profound reassessment of risk and that a significant reallocation of capital is expected. In that letter, and I quote, he stated, "Every government, company, and shareholder must confront climate change." The ultimate takeaway is that investor funding will be directed towards achieving a low carbon economy. It's happening now, and it's going to continue to gain momentum. And as part of that, green entrepreneurship is essential for us to achieve a low carbon world. So what does this all mean to me? Why am I talking about this to you right now? This is the motivation and the impetus. These forces are what drove ASME, the American Society of Mechanical Engineers, to invest in efforts early and in alignment with its mission. For those of you who are not familiar with ASME, ASME is a non-profit membership organization for enabling collaboration, knowledge sharing, and skills development across all engineering disciplines. ASME is a worldwide organization reaching over 100,000 members with presence in over 140 countries and a mission to advance engineering for the benefit of humanity. As part of that mission, We see a vision of a world where everyone has safe water, sanitation, energy, food, shelter, and infrastructure, and can live in health, dignity, and prosperity. Our work is focused on building the pipeline and capacity of technical talent globally to solve urgent challenges and deliver sustainable solutions. We call this engineering global development. Our ecosystem is focused on attracting, developing, and deploying technical talent and accelerating impactful solutions. A decade ago, we started with our Engineering for Change digital platform and community, and have since evolved to delivering training to hardware enterprises who are working to achieve social and environmental impact, and delivering platforms that enable the convening and advancement of these diverse efforts. ASME's iShow is a unique offering for advancing hardware-led social innovation, taking place annually in India, Kenya, United States, and growing with time to expand to other regions. ASME's iShow delivers design and engineering support and expertise to hardware-led ventures around the globe with a social and environmental impact. I'll encourage you to learn more by visiting our website. In addition to that, we have Engineering for Change, our platform for knowledge as a public good, connecting a global community of over 1 million engineers, technologies, and development practitioners around the world, where everyone can come and for free learn about the latest developments, tools for design and sustainability, best practices, and opportunities for themselves to participate as contributors to this important arena of technology for good. Having done this work for over 10 years, we've learned and seen how green entrepreneurship can advance sustainable development. And from this, we've also seen how the sector is evolving at large. Starting with a decade ago, what we've been observing is a true paradigm shift in how people in developing regions are observed. They're no longer seen as aid recipients, but frankly as consumers, innovators, entrepreneurs who are contributing to improvement of quality of life. While they may be economically poor, they are ability rich. And within that, technology is the key enabler to empower and involve people, reduce income inequality, and advance global development. We call this intersection technology for development. And there's been a growing ecosystem of individuals and organizations who are contributing to this sector. In industry, participants such as Tata and GE Healthcare and Toyota and J&J. In academia, we see examples across the globe of labs dedicated to advancing this sector of engineering global development, such as MIT's D-Lab, UC Berkeley's Blunt Center, Makerere University in Uganda, and IIT Delhi for Center in Research and Development Technology in India, just to name a few. There has been a growth in social entrepreneurship and social enterprises developing solutions, market-based solutions to advance quality of life. And of course, and non-governmental organizations and multilateral agencies who see technology as a critical tool in their toolbox to achieve the SDGs, including WHO, the World Health Organization, and UNICEF Innovation, just to name a few. And the sector continues to evolve, as it should. You'll see this even in the nomenclature. It's been called everything from technology for SDGs and tech for good, frugal innovation to technology for development, engineering for global development, and humanitarian engineering. These names all amount to the same goal. One universal truth that we have learned over time of doing this work in all over the globe, and something that you will hear often from practitioners, is that technology does not work on its own. And that is very much a truth. However, what we have also learned is that technology does work, and technology is essential for meeting the goals, but it requires the right strategies and the right people in place to be able to meet its objectives. So I'm going to provide an example of what I mean about having the right strategies, the right people in mind, in particular in terms of green entrepreneurship. So this case study is aligned to the needs related to global energy challenges. Energy is the bedrock of socio-economic development. This is evident if you look at the chart in front of you now, which demonstrates the relationship between energy consumption and GDP. What you'll see on the left side of this graph is the countries that are lagging in terms of electricity consumption and those who are at the higher end, and how that corresponds to higher GDP per capita. Now, this global energy challenges are particularly prominent when you're looking at the rest of the world, particularly in developing countries. At this time, 2.5 billion people are without access to reliable energy. That is 1.3 billion who are not connected to the grid, and approximately 1.2 billion who are without reliable power. In Africa, sub-Saharan Africa, what you see in terms of the graphic here and percentage of population without electricity amounts to approximately 600 million people. And those consumers, because they are consumers, spend approximately $70 billion on traditional energy sources in rural Africa and Asia. So the question would be, why not put grids everywhere? Well, the sustainability or the rationale for putting in grids becomes really challenged when you see that over 30% of aggregate losses from grid extension make central grids really economically unviable. This is directly aligned to Sustainable Development Goal 7 of affordable and clean energy. What we see for the communities that need access to reliable electricity, those in particular in rural areas who are off-grid, and where the cost of grid extensions is prohibitive, is that grids can't be seen as the sole or even primary answer to the provision of electricity for all. And what's exciting is that advances in technology are rapidly changing the options available beyond the grid, and many of those advances are being led by green entrepreneurs. So with that, I'd like to share the example of Husk Power System. Husk Power Systems started out in 2008 in the rural state of Bihar in India, servicing the agro-processing communities there through a uniquely designed biomass gasification plant, what is essentially a micro-utility. Their footprint was serving approximately 1,000 households with a combined power demand averaging of 20 to 30 kilowatt hours. One 40 kilowatt electrified Husk Power Systems plant was able to provide electricity for 500 village households. And customers in that village were paying approximately $2.20 US per month for a basic connection to supply approximately 2 15-watt CFL lights and a phone charging capacity, plus about 300 rupees for a connection. Now, this was a really beautiful circular relationship because those agro-processing communities were in fact growing rice, and the rice husks were powering these plants. But the downside was that power was intermittent. So it would come on in the evening and turn off sometime in the night and remain off until the next evening because the biomass gasification processes had to match what was the input and who was available to work. There was no storage capacity really. So Manoj Singhal, who's the founder of Husk Power Systems, was observing these changes, at the same time seeing the growth of the photovoltaic sector going in leaps and bounds, and recognizing that he would need to adapt this enterprise, Husk Power Systems, to meet the demands of his customers, as well as to match to the evolution of the technological innovation in this space. He did just that. He developed a strategy along with his team for scaling from a micro utility to a broader rural utility, and going from India into also Tanzania. So what he did was combine the original technological development of the biomass gasification plant, where they're taking in the biomass waste and gasifying it to produce energy. And this is done in the evening. And then combining that with solar photovoltaic, where they are developing solar power farms and leveraging solar energy. And That energy and the technology behind it allows them to be grid compatible, delivering three-phase AC power, empowering households, small and medium businesses, and factories. All of that is combined in their synchronization command center, where they are actually able to manage their customers, understand their needs, and manage their demand, um, and deliver this storage of power, distribution, as well as remote monitoring of payment, and able to deliver backup. So they leverage solar photovoltaics during the day, biomass for nighttime energy, and enables them to deliver continuous energy supply to this customer base. This robust and smart rural utility leverages smart meters to enable implementation of the optimized tariff plan. And what's exciting, which a challenge that you see in many rural settings, is theft of power. But what they've developed is non-standard high voltage to prevent theft, and they have been able to record a theft rate of 0. They have also been able to access real-time data on individuals' energy uses and have remote management of meters. This is really phenomenal and, quite frankly, progressive in a space where these kinds of options are limited. Now, that allowed them to diversify also their customer base to not being just individual households, but also shops, retail, and factories, because now they were able to provide 24/7, 365 reliable power. So for households, this included also access to beyond lighting and beyond just phone charging, but access to appliances such as TVs and refrigerators. For shops, this allowed for access to machines such as freezers and printers. And for factories, three-phase power for machinery, particularly in food processing, again, given the fact that oftentimes it is serving those communities. And this also had tremendous impact on quality of life more generally. One of the issues in emerging markets and many of these rural settings is the reliance on kerosene for lighting. Kerosene lanterns are dangerous. They not only emit smoke, but are also dangerous if there are children, as they are often overturned and create fires. And one of the exciting outcomes in surveying done by Husk Power Systems of their customers is that they reported 0 kerosene usage in their homes. In addition to this, their system actively promoted machinery uses, with 84% of their commercial users evolving their business with Husk's reliable supply. Again, those three-phase AC power opportunities equipped their customers to buy printers, freezers, and refrigerators. This journey, as of today, which is now in 2020, 12 years this took of understanding what were the needs of the customers, how technology, evolving technology was going to be integrated into this enterprise, rethinking and frankly hustling to be able to arrive at a place where Husk Power Systems is now positioned to impact 10 million people by powering 2 million households and businesses around the clock throughout the year. They are now the most experienced mini grid operator with operations in India and Tanzania, operating 70 hybrid mini grids. They design, build, and operate mini grids using 100% renewable energy. They have one of the lowest capex and LCOE mini grid operators in the world, and they have closed over $25 million in equity from strategic investors in 2018. This did not come lightly. The Husk Power Systems story really highlights that green entrepreneurship is a complex and iterative process. What we have in front of you is what we present on Engineering for Change, our solutions development process. While it seems linear, what you will see here is the circular nature of this process, the iterative elements embodied within this process demonstrate that as an entrepreneur, you need to continuously learn, continuously observe, and certainly co-create in order to achieve sustainable solutions for communities around the globe, particularly underserved communities. I thank you for your attention today. I thank you for your time, and I welcome questions. You may contact me at the email address listed on the slide. Thank you very much, and have a great course.